All right, guys, in today's video, we're going to be showing how to rebuild a non-user replaceable battery pack. And we're going to use this Black Decker 15.6 volt dustbuster as an example. So this is kind of like a two-for video. We'll both do a repair on the specific appliance as well as talking about the generic repair approaches of non-replaceable batteries. This is a model CHV1568 Type 2 Black Decker. And what we're going to be doing to get it open, we're going to release the snout here so that we can expose all of the fasteners. There's two Phillips head screws in the handle on this model. There's two in the body here. And then we remove the snout because there's two more here and here. And so the first thing we're going to do, and also there's one right down here on the little charging bracket. So first thing we're going to do is pull all 7 of these screws. And they're all going to be very similar. So the ones in the body and the handle are going to look like this. And I'm pretty sure this guy down here looks like he's going to be a little bit different. Let's check. Yeah, so the one on the bottom's a little shorter. So we'll go ahead and pull these and then we'll resume. All right, we got 7 screws, 6 long and 1 short. Next thing we're going to do is we're going to twist off the filter, and we're going to remove little attachments from the cubby hole down here. And with all that out of the way, with those 7 screws removed, we should be able to separate this guy. Just going to use a little plastic prizing device to give it some persuasion. There we go. All right, we got a filter attached to this side of it. Just super dusty. And then this little guy popped off. Just take note of where everything goes. This guy right here. And this is our battery pack right here, this white plastic. And there's our motor. And so we just had one more thing we want to get out of here. There's a little plastic cover around this charging LED. Take that out. And now we want to work. So 2 things, right? We don't want to accidentally activate the power switch until we can get the motor and the battery disconnected. And so this guy just kind of sits in here. And the motor looks like it's wedged in to this little plastic housing cap. So let's see if we can work that off. Whenever you're working on stuff like this, you just want to go slow and gentle. There's no service manual on this because you never were supposed to come in here and change anything. All right, so what we're going to do here is we needed to get the little metal tab out of the plastic housing right there. That lets us work this off. You can see here, I'm just trying to get this basically unplugged from the motor. I'm trying to get it out without having to take the whole kit and caboodle out, but we might have to take the whole kit and caboodle out here. There it goes. All right. All right, so now we'll take a pair of pliers and we'll disconnect the motor so we don't have to worry about it coming on. There's this. There's the negative one here. All right, there we go. And then while we were doing that, this little piece of trim popped out. All right, so there's our battery pack. There's our little charging LED. We want to get that back in here. We accidentally knocked it out. All right, that just sits in like that. And so this guy, let's see how he opens up. So it looks like there's little tabs along the sides like that. One here. For some reason this guy, oh, there he goes. All right. And there's the battery pack. And what the first thing you notice is here, so this is not normal batteries, so it's not user replaceable. What you've got here is a series of cells that have these connections between their plus and minus sides spot welded on with these little metal strips. It's probably nickel. And so what you have to do to replace something like this is you have to get these individual cells, re-spot weld or solder these connections, depending on the approach you take, in order to rebuild this. So we should find that this piece here so this piece here probably makes contact inside, so we can just kind of take this out as a unit. Just want to keep it together so you remember how it goes. And then this would be where the terminals are, right? So all of this wired up in series. There's your positive wire and there's your negative wire. And there's a little insulator here that we want to salvage. And again, you want to use plastic. You don't want to use anything metal that might short something. Let's see if we can get this off here. It's just kind of aged on and stuck. There we go. All right. So let's talk about what we replace this with. So let's get some of this stuff out of the way and let's go over replacing it. All right, guys. So the other thing I did is I peeled off this insulator because we can see there's a connection that goes from the negative of this cell. And if we flip her over, it loops over and goes to the positive of this cell. So that just gives us an idea about the number of strips we need. So the type of battery here, if you take a C cell, you can see this is smaller than a C battery. And it's what's called a SubC battery. There's actually two sizes you can get. You can get a C, you can get a SubC, and then there's one that's a little shorter but the same width as this, and it's called a 4/5 C. And this particular guy here, if you look at a regular C battery, it's going to be somewhere in the neighborhood of, it's going to be north of 25 millimeters, 25 or 26 millimeters, depending on the brand. And then make sure we grab it on the insulation side. It's going to be somewhere around 47 to 50 millimeters in length for a C battery. One of these sub-C batteries, on the other hand, is going to be in the neighborhood of 22, 23 millimeters in width. And then as far as the length, just want to make sure we're grabbing it on an insulated side here. So this has got like a paper insulator there. I don't want to short anything out. So this is going to be in the neighborhood of 42 high. So that's just a different kind of batteries you could see. So what we're going to replace these with, we're going to use this Tenergy brand, and we've bought a pack of 15 of these sub-C batteries. You want to get the kinds that do not have leads on them, and so what you'll see inside is a very similar battery to the one we have, right? So negative side, positive side, identical size, right? These here are marked as 1500 milliamp hours. If you can see this side here. Couldn't really find anything that small anymore nowadays. And I think these were, there they are, 2200 milliamp hours. So these are slightly better. So the process here is going to be, we're going to line these up using the original case cover, like a jig. Right, so just going to go just like this, replicating what we see here in the orientation. And we'll get all of these different connections welded on or spot welded on, and then we'll flip it over and we'll do the same thing. So this has got two negatives on this one, and then a positive, and then we've got a negative, positive, negative, positive. Just like that. All right, so we'll do the connection here, 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 and here. And then what we'll do on these two is we'll just have a small strip that we'll end up welding these leads onto here and here. And then we'll flip it over and we'll do the same thing that they have on the other side here, right? So we'll end up doing a mirror image of this side, and we'll end up doing this one, this one, this one, this one, and this one, and this one. Then when we're done, there'll be one more, which is this long one that goes from the positive of this battery cell over to the negative of this battery cell that they've got this little piece of insulating paper glued to. We'll do that one last. Actually, just going to remove that right now before it gets damaged. That's in there just to make sure there's no chance of this touching that. In fact, you know what? That is probably a good idea just to leave that there until we're done. So what I'm going to do now is I'm going to get set up to spot weld those in. I'm going to take this out to the workbench. We've already cut some strips. All right, we've already cut some nickel strips that are approximately the same size and approximately the same thickness. And then we're going to spot weld them into position, matching what we see. All right, so let's go ahead and get started with that. All right, guys, we're moved outside here on a workbench. I wanted to show you the power pack, the original power pack's voltage, because it's fully charged. You can see we're reading 15.46 volts out of the 15.6 it's rated for. We want to get something similar when we get all done here. The problem with the original battery pack is it just doesn't last more than a few minutes. It's just gotten all aged out. So we need to replace it, right? So here we've got the cells in the correct orientation for this side in the case. We're using the case half as a jig here. Just be careful on the LED while it's down here that don't damage it. And then we've got a rubber band just to keep everything nice and taut. There's a lot of these different kind of spot welders that you can use. I'm going to be using this one from CSI. This is the latest firmware version. The one before this was pretty good too, that's in a black case. The difference here is the newer one, the firmware measures the power output in terms of a percentage, right? So we're going to start probably around 45%, see how that goes. The older ones that are black, and even the early versions of these gold ones, had some kind of Chinglish power notation called gears. Right? All it meant was a power notation. The percentage one's much better. So what we're going to want to do is we're going to want to get a feel for the right power to get a good weld joint here. So we're going to take one of our strips, and we're just going to do this guy right here to start with. And all this does is these types of tools, right? We've got it set up. We're just trying to center this. We've got this set up so that it has a 1.5 second delay before it does the actual spot weld. And so the firmware inside the device can detect when it has current. It'll delay 1.5 seconds, and then it'll do the weld. And so what we're looking for, those look nice, and we're just going to give them a tug to make sure that that's the correct amperage or power output for the thickness of the material, and that looks great. And so all we're going to do now is we're going to go give 2 more of these on each side, and then we're going to do this one. All right, and so that's all you do, right? You're just going to go down and do that. It looks like 45% is a good setting for the particular thickness we're using. Now we're going to go do this side here. The key to getting these kind of tools to work really well is you don't want to push down very hard on these electrodes. Just kind of want to tap down on them. I'm trying to get this guy in a position where it doesn't damage our LED on the other side. I probably should just take him off so we don't have that kind of drama. So we're just going to kind of lightly hold it here. Getting a little bit of sparks tells me that we have the correct amount of tension. And that's what we're going to do. We're just going to keep going around, just like the factory originally did, rebuilding this whole pack. We're going to put one here, we're going to put one here, and we're going to put one here, and then we'll come back. All right, guys, so we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we're going to flip this guy over. We went ahead and took our LED assembly here off just so it didn't get damaged. And then what we're going to do is we're going to reposition this in the other direction now in this jig. So let's get this guy all repositioned, and then we'll come back and we'll do this side. All right, guys, so now we're just going to replicate this side. Same process. Doesn't matter whether you do the negative or the positive side of the cell first. Just make sure you don't press down too hard. Now, a lot of times, you know, it's cheaper just to replace the device. But, you know, if you got a battery pack for some power tools, or you've got a discontinued item, it's much better just to do what we're doing here and rebuilding this thing. That's the whole reason they make these batteries available in the first place, so that you can do what we're doing right here. So I like this particular CSI spot welder. I would prefer that the leads be a little longer. It takes forever to charge it too. I would say it took about 10 hours the first time I got it to charge it up. I don't know why that's the case. Just a very inefficient charger. That was hooked up to an iPad grade AC adapter as well. All right, but hopefully you guys are getting the hang of this. And again, you know, you can control in the firmware for these things how long you want it to go. I guess we'll do this side first so that it quits walking around on us. How long before it detects that there is current flowing before it actually does the weld. And sometimes, you know, people say, well, you know, these things don't go through very thick pieces of metal, and that's true. They're not going to work on 0.2 millimeter. They work up to 0.15 probably. 0.1 will handle about 3 amps. 0.15 will handle about 6. If you need more than that, you're probably not going to be able to get away with an inexpensive tool like this. But for the kind of stuff we're doing here, and just getting common household appliance battery packs rebuilt, it's fine. It's more than enough. All right, so we got 2 more. We'll go ahead and do these off camera, and we'll come back and we'll show how we solder the leads on. All right, guys, the last one we've got is this long strip. So take our rubber band off. We're going to kind of take our pack out of this little holding jig. So we're going to get this long strip that goes around the positive of this cell. So 1, 2, 3 in, and then it's going to bend over and go up against the negative of the cell right next to it. Right, the one here. So to get this, I think what I'm going to do is, I'm just going to bend it up first. The right length. Then I'm going to come in from the side, bend it down. Let's just see what this looks like. Yeah. Go ahead and bend it right there. Key to this is we just don't want to short anything out. It's just an awkward kind of piece, but there we go. We've got it. All right. Now we just got to spot weld it into position. So hold it down with one of our leads. Then we can get the other side. All right, that completes all of it. In fact, we should be able to come in now with our meter. Let's see what we get here. 16.96 volts. So we've got our pack wired up. All right, so the last thing we've got now is we need to replicate this. So what we're going to do for that is we've cut a couple of small strips that we'll just give 2 spot welds on, right? That we'll put on here and here. And what we're going to do here is we're going to unsolder the wires from here and solder them onto these 2 strips. So let me go unsolder these and solder them on the strips, and we'll pop those strips on. All right, guys. So we soldered on these 2 little pieces, and we spot welded them. And then we glued our insulator back into position. So now we're just going to continue to do our final reassembly. Put it back the way we got it. We first started earlier in the video, so we're going to get all these snaps. All right, so everything's snapped back together. We put our LED board back on. And now we're going to want to reconnect our 2 connectors to the motor so that we can put this guy back on. So the larger one is right here. Hopefully you guys can see that. And the smaller one is right here, right there. That in position like that. And then these 3 terminals here, 1, 2, 3, make contact with the motor here, here, and here. So if you remember, this is the piece where we had to kind of wiggle and wedge to get it back in there. It might just be better in this case. I think what I'm going to do, just to avoid little old plastic popping and snapping, is just get the motor completely out of here. See if we can see how she snaps in. And try to put the whole thing in as an assembly. That's what I'm going to try and do. Unplug this again. Just got to go nice and slow. We don't want anything to break. You can see that it fits in these little prongs in the back, right there, those 2 prongs in the back. And then it fits into this little snout here in the front. I'm trying to get that to kind of let go right here on this lower corner. I don't know, maybe I'm being too gentle with it. We'll see. There it goes. All right, it just takes quite a bit of force to get it to unsnap from this kind of center support here. All right, let's do this again. One connector. Two connectors. Okay, now she's all plugged back in. All right, so we got this adjustment nozzle out of its track so that it's got some flex to it. This flange fixed into this groove, and then you got 1, 2, 3 male pieces that fit into these 3 female pieces. So line up the flange, line up all those males into those females, and then get the nozzle in here and then work it back into the groove that it's supposed to be sitting in. Just be very gentle with it. And then we want to get it where the little tab here snaps into position in the back. All right, so you can see the tab that's going to make contact with the charger. All right, and just double check that this mechanism is working okay, that you didn't bind it up. And at that point, we're ready to put the other top half on. So we've got the LED, has a little cover here. We'll put it in the position right there. And then we've got the power switch. We've got the release for the snout. Whoops. Didn't want to stay in there. All right, we've got this little trim piece. It looks like it fits right here. I think it fits like that. Let's try this direction. Nope, definitely fits like that. All right, you got that piece there. And then we've got the filter. It fits like this. Okay. And then we've got the handle piece. It fits like this, I think. Nope, had it right the first time. All right, so now we got to get this top case on with all these pieces. I'm going to have to hold this little guy in the front here because he's going to want to walk. Let's see if we can get everything snapped back in. And the same deal, we want to get this little charging tab to pop through for the battery pack, just like so. I think we're all good here. We can start putting our screws in. So let's start putting our screws in and reassembling, tightening it up, and then we'll give it a test. All right, guys, we've got all of our screws retightened down. Remember, the short one is the one that goes here, and then the 6 long ones go elsewhere. Everything is in position the way it's supposed to be. We've also given it a quick test. Sounds nice and powerful. Our adjustment still working fine, so we got that back in the groove properly. We're going to pop it on the charger, charge it up, and it's done. I hope this helps you out, not just for a particular dustbuster kind of repair, but for how you can go in and rebuild these types of small, non-replaceable battery packs, whether it be for a cordless appliance like this or a pack that goes on your cordless tool or what have you. You can rebuild those. I'll put links in the description for these tools and for this particular type of SubC battery. I like these Tenergy ones, but there are other brands as well. I'll put links for both those in the description. If you got questions or comments, go ahead and leave them below. I'll try to help. And as always, thanks for watching.